What we have next, guys, is 2017 4B on connected particles, okay? So part 1, show on separate forms the forces acting on the wedge and on the particles. It says smooth surface, so what does that generally mean?
No friction.
Huh?
No friction.
No friction, okay? So, what we have here is, we'll call this force R. Okay, so R goes up, mg goes directly down. You happy enough with that?
Yeah.
And you have to show them separate diagrams as per our marking scheme, okay? Now, do we have an angle? We have an angle beta. What does that make this? Beta. Which makes this mg cos b, and then mg sin b. There's no friction opposing the motion because it says it's a smooth horizontal surface. Okay, system is released from rest. I haven't shown anything on the wedge yet. What do we expect to happen with the wedge, guys? So what weight is the wedge? So 4g going directly downwards. What else does the wedge experience? Reaction force R going straight into it. Okay. What can you tell me about this angle here then? Beta, because that's 90. That'd be 90 minus beta, which in turn makes that one beta.
Do you show that? How you get beta?
What?
Do you need to show that?
No. Okay. So, next thing, I close off that right angle triangle, and then I get R sin B and R cos B. Is that right? R sin B, R cos B. Find particle moves with acceleration P relative to the wedge, and the wedge moves with acceleration Kp cos beta is the acceleration of the wedge. Find the value of K and show that P equals this here. Okay, anybody remember our system?
The acceleration.
MA. In which direction? Yes?
Do you not do an acceleration triangle?
Oh, you do. You would, normally. But acceleration triangle for the... Trying to think now. Oh, an acceleration triangle for this. You're dead right, we do. Okay, so we're about to do an acceleration triangle for the wedge. Right? So to do the acceleration triangle, what we always do is we always extend your line like this along the bottom. We do exactly the same thing, except we close it off at 90 degrees. Everybody see your acceleration triangle now? Okay, I'll bring that all down in just different pieces. Okay, and you'll see what happens here. Okay. And that's meant to be a bit sharp. Now, with your acceleration triangle, your hypotenuse is always the acceleration of the wedge. So that's our Kb cos beta. Okay. What's this part here then?
Cos beta is cos beta.
Cos squared beta, and the other one? Kb
Cos B sin B.
cos b sin b. Good job. You can see your cos b sin b in your marking scheme, can't you? So we're actually reasonably confident we've actually done something good there. Okay? So I'll just rid myself of this for a minute. Just place it down the very bottom so I can check it later on. Just leave it there. Hopefully you will get k equals a fifth. Now here's what we're going to do. Let's start off with parallel to the plane. Okay? So what's the weight of our particle again? It's m, isn't it? So it's going to be mp. But there's a problem there as well. P goes this way. What goes against it?
K consistence for everything.
Okay? And what will that equal? What's the forces up versus what's the forces down?
Mg sin beta.
Yeah, I think that's it. There's no other forces opposing that, right? So that's parallel. Where's perpendicular?
mg cosine b minus or.
Sorry?
mg cosine b minus or.
Yeah, it's mg cos b. Oh, by the way, I forgot to put a restitution force acting against the wedges diagram, by the way. So mg cos b acting diagonal. Is it diagonal right down, yeah? What acts diagonal left up then? Huh? Or? What part of the acceleration is diagonal right down? kp cos b and sin b. You see we've introduced r there, haven't we? So this was one equation. This is the second equation. Now what do I have to work on? The wedge itself. And we're not going to use the wedge going up and down. How do I know that? Because we'll end up introducing n. And n isn't in any other equations. You get that? It's going to be pretty useless. So we're going to do the wedge going parallel to the ground. Okay, so let's have a good look at the wedge. What way do we think the wedge is working? So we have what way is it again? It's 4m. What's its acceleration? 4m kp cos b. You happy enough with that? Okay, that's its force. What's driving it to the right? Just r sine beta. Okay, and finally, that is our last equation. So here's our three equations, and what we're looking to do with all three equations, trying to find the value of k. Alright, and we know that k comes out to be a regular value, okay? So let me see, how are we going to work this out? There's a bit of organising here. I reckon substituting out the r's is an absolute must. Would you agree with that? So what can I say? R equals R equals 4 mkb cos b over sin b, and we can leave it like that. You could put 1 over tan beta if you wanted, but I just might leave it as sin and cos for a minute. Okay. What are we going to do with that then? So I've essentially used this. I've used this equation here. Okay, so that can sort of disappear up.
Sub it into the green one.
I'll sub it into the blue one, is it? Yeah, sorry, yeah, it's slightly off. Okay, so substitute that into the blue one. So what do we get then? mkb cos b sin b equals what?
mg cos b.
Huh?
mg cos b.
Yeah, let's go down here for a second. Put down that red one here. No. Wait a sec. Where'd that red blob go? There.
It just cut the colour.
Huh?
It just cut the colour in it.
Yeah. I'm just gonna bury that down the bottom. I'm gonna need it later. Okay. So what did we get on its own again? Oh, that there, wasn't it? But that was R on its own, wasn't it? So now we're plugging it into the green slash blue equation. So it's mg cos beta minus 4 mkp cos theta over sin beta, yeah? And that equals mkb cos beta sin beta. Is there anything that can disappear out of everything? Sorry? The m's can go, can they? What else can go? Cos betas can go. So what we left with, kp equals g minus 4 over sin b.
There's a sine.
There's sin b there as well, wasn't there? So what does that mean? They're compatible with each other then, aren't they? So I'm going to do a for here, a for here. Oh no, that's not what I'm going to do. What do I have to do? A sign here, a sign there, isn't it? Have to sign everything, do it. Sign B underneath, sign B on top, sign B underneath. We'll just finish this one off before we go sign B on top. So what do we have now? We have KB sine squared B minus plus 4KP equals G sine B. Okay, I've essentially gobbled up now. I have to use the yellow one now, don't I? So what am I going to substitute in for the yellow one? What do we have in the yellow one? We have MP, we have A, KP cos squared B, we have an MG sine beta. What letter do I want again? I want K, don't I? K is essential, so what do I need to I need to isolate P and get rid of it. Okay? So I'm going to isolate P and get rid of it using the bottom red equation. So here we go.
Could you still sub in and G sine beta?
Just let me do the. So you want me to do what?
So if you get rid of the ends on the top equation,
I can't. There's no. Oh, there is. Yeah, the m's are gone. And then what do you want me to do?
then you have G sine beta equals KP sine squared beta plus 4KP.
Good point. Owen spot a quicker way for me. KP sine squared beta plus 4KP equals what was it? P minus KP cos squared beta. Is that okay with you? How you asked me to do, was it? Okay. Did I drop a K? I didn't drop a K there at all, did I?
No, that was MP. So change cos squared to 1
I
minus.
still have P's everywhere though.
They cancel.
Yeah, they'll cancel.
Oh, the P's cancel. Yeah. Ah, perfect. K sine squared beta plus K cos squared beta?
K.
Huh?
It's just K.
It's K, isn't it? So it'd be 0 equals K.
Is it 1?
Yeah, it's just 1, isn't it? Cos squared B plus K sine squared B plus 4K. Did I leave a 1 somewhere behind? Huh?
On the left.
If you factorize the K's out.
There should be a 1 somewhere.
Yeah.
Oh, that's a 1.
Yeah.
There we go, we're on the right path now. So it's going to be 5K on the right, 1 on the left, 5K on the right. K equals the fifth. Okay. Show that P equals 49 sine B plus 4 sine squared B. Okay. So did we go down here? So did we get P on its own at any point in that equation? I think it's very much just subbing in. So if we just quickly belt onto the marking scheme there, we would have got this earlier on, wouldn't we? Your mg would have been this equation, these two equations here. Just let me copy and paste them out. Okay, so we had these two equations earlier, we used them earlier on. Okay, I'll just pause it there, lads, if you just have a look at it again. And I lost the basically